Good morning, students. Now we are going to discuss on the topic recursive design parsing from Unit 2 of your Principles of Compiler Design subject. So, recursive design parsing, which is going to be important topic on the basis of top-down parsing. So, here we are going to use some various concepts which is related to derivations, add parse trees, and then various conversion process that we have in context-free grammars. So, from the name recursive design parsing, we could understand that we are going to use some recursive procedures in this parsing process. So, parsing process in the sense very simple. From the output of lexical analysis phase, we are going to take something and then we are going to construct a parse tree. So, the parse tree, which is going to be a graphical representation, a tree structure of your expression. So, to construct these syntactic tree or parse tree, we are going to use this particular procedure named as recursive design parsing. Recursively, we are going to use some productions until reaching the terminals or reaching the input strings, whatever that we have to derive. So, this is going to be the introduction about recursive design parsing. And then here, coming to the concept named as backtracking. So, what is meant by backtracking? Always the questions may arise. So, from this key term, what we are going to understand. So, that's going to be very important and crucial thing over here. So, backtracking in the sense we used to have some productions, and in those productions, we used to repeatedly we try to apply some of the productions, and we used to convert a non-terminal to a some other non-terminal, and we try to solve the problem and to find the solution for the problem. Suppose if we wouldn't able to find the solution for the problem, we used to go back and then once again we used to try to apply some other production. So that's why we used to call it as an backtracking. So this is going to be one of the key term that we have used in this recursive descent parsing process. So here we are going to use some set of procedures, and then we are going to start from the start symbol, and then we are going to move towards the input string, and then between this dot symbol and the input string we used to have some a number of productions. So in these productions we used to have some various conversions like a start symbol to non-terminals and non-terminals further to some other non-terminals, and those non-terminals are further to some other non-terminals, and finally to terminals. So these are the conversion process that we have over here. So we are going to apply some procedure, common procedure repetitively. So suppose if you would be able to find out the input string, then no problem, that's going to be the solution. Suppose if you won't able to find out the solution, then which is going to be results in an error over there. And then here we have some various pseudocodes, and using those pseudocodes we would be able to understand these concepts of recursive descent parsing. Here the important thing that you people have to keep in mind are for NLP, natural language parsing, the backtracking is not a very efficient one, and then instead of that we are going to use some other tabular methods. We used to call it as a dynamic programming algorithm, or else we used to call it as an the method of yearly, EARLY, which is going to be the name of a person. So he have defined some methods. So instead of using backtracking, we would instead suggest some other technique like dynamic programming or the yearly method, and we would be able to find out some solutions. So we have some alternatives instead of backtracking over here. The purpose of avoiding backtracking is, in backtracking we have some problems, because we try to solve some problems and then we won't have some solutions, and then there will be some wastage of time over there. So instead of following those procedures, suppose if we have some other alternatives, we would choose those things to solve a problem. So that's the thing that we are referring over here. Okay, and then this is going to be the algorithm that we have. So you have void a, which is going to be a procedure. So the entire procedure which is being named using a function a, and then you have some set of productions. So here we have mentioned as choose an a production. You have some various non-terminals over here, or else we could consider these as in productions as x1 comma x2 comma x3 up to xk, and then instead of k we could replace any number of things over here. And then we have used some for loop for I equal to 1 to k, and then in this for loop we have used an if else statements where you have an if and you have a condition as if xi is a non-terminal, and then you could call in procedure of xi. So whenever that you're going to call the procedure of xi, you will have some replacements from non-terminal to some other non-terminal, or non-terminal to a terminal. Suppose if not, else if xi equals to the current input symbol, so we are going to stop the process and then we're going to move the input to the next input symbol. So suppose we are trying to take x1 and then we are trying to apply some productions, and then x1 which is going to give some other non-terminal. Okay, it's good, and then we are going to move to x2. So like that we are going to repeatedly we are going to apply all those productions, and then finally we are going to reach the input string. Suppose if in any one of these conversions, if suppose there is going to be any problem, and then we used to call it as an error over there, or else in else we have mentioned as an error has occurred. So here recursive process which is being applied in applying the productions whatever that we have in this set of EA productions. And then once again they have given the explanation for backtracking. The code of needs to be modified. So those whatever the code that needs to be modified, for the modification purposes we are applying this backtracking process. And then here as per this algorithm, as per the line 1, we should repeatedly we used to try to apply the protections, and if there is going to be solution then it won't be a problem. Or else from line 7 you will have the statement class which is going to be results in an error over there. Okay, so these are the things that which has been explained while comparing the process of backtracking and its corresponding algorithm. And then the next thing here which is going to be the input pointer in the sense which is going to be like a string, or which is going to be like an arrow mark. So this that particular arrow mark which will be used to denote, so what is the production that we are going to apply. So for example you're going to apply the production number 1, and suppose if you have completed that particular production process, and then we used to move to the next production, the production number 2. So these types of movements from production number 1 to production number 2, we used to move the input pointer from production number 1 to production number 2. So these types of movements we used to use a pointer named as input pointer. And then this is going to be an example here where you have two productions as S gives C capital A D and A gives A B or A. So here actually we have used the backtracking process while comparing the step B and C. So in step A, simply we are going to take the capital S, and then we are going to convert into C, capital E and D. So you will have root node as capital S, and then you have various leaf nodes like small c, capital E and small d in step A. In step B, we are going to take the middle of the leaf node, the capital A, and then we're trying to first we are trying to convert the capital A into AB. But here the objective for us here is to derive the input string CAD. But here, while applying the second production and then converting the capital A to AB, there won't be a solution for us to derive the input string CAD. And then once again in step 3 we are using the backtracking mechanism. Once again we are going to take the capital A production. So instead of applying AB, now I'm going to apply small a alone. Now finally we have reached the solution, and the solution which is going to be CAD. So this is where we are applying the concepts of backtracking. So whatever the thing that I have explained to you, the same thing which is being given as explanation over here, where the W which is going to be input string, the input string we have CAD, we have to reach this input string. So for that we are going to use these two productions, where capital S which is going to be the start symbol and W which is going to be the input string. So by applying these concepts and recursive decision processing and backtracking concepts, we are using some parsing process, and then the solution for us, the objective for us is to derive the input string CAD, and finally somehow we have reached our objective. So these are the various things that you people have to keep in your mind, like what is meant by parse tree, and then what is meant by recursive descent, parsing, and backtracking, and what is meant by input pointer, and what is the algorithm that we have used over here. In that particular algorithm, how we are applying the backtracking process, and then we have an example to derive the input string CAD, and to derive this input string, how we are using the backtracking process, and then we are deriving the solution for this problem. So these are the various important things the students you people have to keep it in your mind. So thank you for listening, and thank you.